Here we will solve some simple differential equations, getting used to some terminology we're about to introduce. So here in example 4, part A, we want to find the general solution of a first order differential equation. To do that, we have our differential equation, x prime is equal to sine of t. So to find x, we can simply integrate both sides on this particular differential equation. And of course, we integrate with respect to t here because x is a function of t, or x is assumed to be a function of t here. So we integrate the left-hand side, and we just get x, really x plus c, but we're not going to write that yet for a reason we'll discuss in just a moment. Then we integrate sine of t dt, and we get negative cosine of t plus some constant c. Now, I didn't write a plus c on the left-hand side because we could have just moved it over to the right at the end here and just put it all together and add a plus c here in the end. And this is what we call our general solution to the first order differential equation x prime is equal to sine of t. Now we want to continue on and solve the initial value problem. So in other words, if we happen to know some value, such as x of 0 is 1, then we can solve for our c here and get a specific equation instead of the general solution. So let's do that for part B. We had that x was equal to negative cosine of t plus c. Plug all of this in. X is equal to 1. So this is negative cosine of 0 plus c. This implies that 1 is equal to negative 1 plus c, or in other words, c is equal to 2. So then our equation is x is equal to negative cosine of t plus 2. And this solves our initial value problem. All right. Now let's do the same thing for example 5. But here we have a second order derivative. Let's find the general solution here. So we start with x double prime is equal to t squared. So again, we take the integral with respect to t. And we get x prime is equal to 1/3 t cubed plus c1. And here's the general solution for just what x prime is. But really, we want, of course, what x is. So we integrate again. And the integral of x prime with respect to t is just x. And then the integral here is 1/12 t to the 4th plus c1t plus c2. And this is our general solution. So the answer to part A here, to the differential equation, to the second order differential equation, x double prime is equal to t squared. So we'll write that down up here. So I can erase this. And we can take care of part 2, or part B here. So part B, we had x prime was equal to 1/3 t cubed plus c1. So here we need to find out what c1 is. We can plug in x prime of 0 is 2. So 2 is equal to 1/3 times 0 cubed plus c1 implies that c1 is equal to 2. So x prime is equal to 1/3 t cubed plus 2. Also, we know then that x is equal to 1/12 t to the 4th plus 2t plus c2. And then we can plug in x of 0 is equal to 1. So we get here that 1 is equal to, I'll write it out in just a moment. So we get 1 is equal to 1/12 0 to the 4th plus 2 times 0 plus C2, which implies that C2 is equal to 1. And furthermore, this tells us our specific solution is 1/12 t to the 4th, or really our particular solution is 1/12 t to the 4th plus 2t plus 1. And that is our particular solution to this initial value problem. And that's where we'll end this video on the introduction.